Yes, what we're going to look at in this video is a really simple program in a schematic PLC. So when we go to the PLC, what we have done here is inserted a CPU, and to program it, it's under here program blocks. And what is automatically inserted here when I insert a CPU is a task. A task is called organization block in a schematic. We organize the program, and this is what you have to do if I want to make a program here, as I can do it in this organization block. Normally you never program in an organization block. Of course you have to program it, because this is the link to the CPU operating system. So you don't put anything in an organization block, nothing is going to happen. But normally you don't program directly in an organization block, but I'm going to do that. So if I now open this one, so what it offers me now is a program, and this is a programming language that's called ladder logic. And that's we are writing 2022. That's not something you would use in 2022 to make programs. So what I want to do is that I want to make the program in a high-level language. If I look at the properties here, I can move over to the other side. If we look at the properties here, information, compilation, protection, and so on. This is the properties for this block. General. It should say somewhere here what it's programmed in. I want to make a source file, something called structured text program, or SCL, which is a structured command language in the CMOS world. That's what I want to do, but I can't switch here, the language here. I could just switch between a graphical language to two graphical languages. That's offered here, where I can draw my program. And these will be contacts. If I do visual programming, I can put in something called a coil. This is not going to be meaningful for you, but this is how I will program in ladder logic. For instance, and what I can do is in the properties here, the properties I can, and down here too. So I switch to FPD. This is an equal sign. What I did was I sometimes come into my PLC, it's just moving through the CPU and going back out. There are errors here. See, it's red. That's because I haven't assigned any inputs and outputs to my program. But what I'm going to do is I'm going to delete this. So now I don't have a task. So I have to add a task. Again, add new block. Or what do you have here? So this is the context menu. What's gray you can select. What's not gray you can do something. But we can use this one, just a double click on add new block. And this is going to be called tsk for task. And I can call it background. Ground. And it's going to be an organization block. And here you can see I can select quite a bit of this organization block. Motion control. It's pretty advanced. That's something you use when you want to move object using frequency drives or electric motors and stuff like that. What I want is a program cycle, and I want to program it in SCL, which is structure control language, and OK. because now it appeared here and it opened it here. Here we can select. What I want to do is I want to make a really simple program using let's say with Boolean logic. So what I want to do is let's say I have inputs to my PLC, what we call binary inputs. Those are true or false, they're either on or off, and I've got a binary output that's either on or off. Of course, these are what we call variables, and I don't have any in here. What I want to do is I want to go into my PLC tags. There are various ways I could demonstrate this, but I want to make some IO tags. What I want to do first, I made a new tag table, and there I call it GT, global tags IO, input outputs. That's an abbreviation, IO, so it's input and outputs in the PLC world. So if I open this one, double click again, or right click and open, whatever, or in normal programs, if I close this, the default command here is, I can also say I can rename it here. That's just by clicking twice on it. If we use an enter, it's also going to. So what I want to do is I want to set an output that I call y epsilon. Here I wrote y and use a tabulator, and then it suggests it's going to be a boolean. It's going to be input 0 0. That's not important what they are called. Binary output. So then I want some inputs. These could be things that are put into my PLC IOs. For instance, the input could be a switch, like a light switch on off. I just call them X1. X is input. We remember that I had used output first, so I switch that to input. 0.0 is my first digital input, not important. Use tabulator, or of course I can use the mouse and just select there. And yeah, binary input 1. As I want more, I think I plan for 3. C. Now I just mark the entire line. Control C, copy. Mark the next one, Control V, paste. Well, if I have 1, maybe I should have 2. Change this one too. And I wanted 3. Mark that one and paste Control V again, because I had it on the clipboard. 3 and 3. Okay, now I have something to work on in my program. And remember to save. If you don't save and your PC crashes, the work is done. It's not done, it's gone, and you have to redo it. Okay, so these are the tags. Now I have something, variables or tags or something that I can work on in my program. I would never program like this, but this is just an introduction to program. Comments, this is high-level language. Here are common, binary, or Boolean logic. That's what I'm talking about. So this is high-level language, and now I want Y to be a combination of A, B, and C, a logical combination. So a Y tabulator. I use sometimes. Equals. This is an assignment. So what I'm writing after this colon equal is going to be assigned to the output Y. So I want this to be x1 and x2 or x3. So what does this mean? Binary, they're either true or false, or on or off, high or low. But we can use true or and false. On the output, a true output would supply energy to my process. A false output would not do that normally. So what I'm saying here, that it's going to be x1 and x2 or x3. What does that mean? This is Boolean logic. It means that if either x1 or x2 is true, y is going to be true. Because and means, no, not either, both x1 and x2. Both of these have to be true for y to be true. If x3 is false, then both these have to be true for y to be true. But or means that if x3 is true, it's or. It doesn't matter whether x1 and x2 are true or not. Y is always going to be true. This is Boolean logic. You can read this. And means they both have to be true, not or, not either one. Both have to be true. So now I save this, and if I compile my program, so what I'm going to do down here is to get information. If there was something, if I did something wrong, if I were 3.3 here, because I will get a red line under here because 3.3 doesn't exist. And save and compile. Did it compile? How it compiles. DOS is not defined. If I double click on it, it's going to jump right where I did my mistake. I knew it was an error because first I don't have the x33. It's not in my program, and there was a red line under it, so I really need to compile this. Now I can do this again. So now I made a simple program, really simple program with binary logic. So what I did here, what we did now was to make a simple, really simple program in a PLC. So what we have to do next is to test a simple program to check if it works. I describe how it works. If both these are true, then output is going to be true, and so on. And now we have to test the program to verify. That's not a part of this video. That's going to be in the next video. We try to test the program.